and welcome to the early edition of the Space Weather! Looking at the sun at 193 angstroms, we see 0 sunspots. Coronal hole incoming, very far south toward the South Pole there. Low solar activity, but high electron flux. We've got charging hazards. We've got all kinds of stuff. Let's look at 304 angstroms. Some filaments dancing on the eastern limb. And that active region never turned into a sunspot, just a cycle 24 little plage there. Nothing too exciting. As we ramp down from geomagnetic storm conditions, looking at that plage there, you can see that is a cycle 24 activity. Let's look at more data. And here's the real-time solar wind. As it ramps down, we see a very low solar wind density, 0.97 protons per cubic centimeter. Solar wind speed 553 kilometers per second. And we see a phi angle that's looking like a magnetic connection with that coronal hole as the earthquake risk continues and the earthquake drought of 7+ magnitude quakes rolls on. Let's talk about funding the channel. Please do so on Patreon, as YouTube pays us precisely 0 to make these videos. So follow us there on Patreon. It's $9.99 a month. You will receive updates before anybody else. Don't sign up for the $1 level, as that will evaporate on Halloween, on or by Halloween. 10.7 centimeter radio flux at 67 here. I drew in this orange line here to show you where the 70 mark is. That's solar minimum. If it's below that, it's very, very low activity. If it's above that, it's activity. Here's the Gong 2 data. And we're going to see continued magnetic perturbations here. You'll be able to see it on the GOES magnetometer. As the current sheet can't decide which polarity it's in, keep in mind this stuff can change instantly. And this data is 1 hour and 35 minutes old. And there's that GOES magnetometer data. It's going to continue to look choppy here for quite a while. So that's something to keep an eye on. And when I say eye on, the pun is intentional. X-ray flux is totally flatlined. We haven't even seen a B-class X-ray flare since July 7th. And we covered a coronal mass ejection yesterday. Let's do it again. As it often takes 3 days for other agencies to report this stuff, we usually see it a few hours after it happens. And here it is yesterday. Let me just show you that coronal mass ejection. You can see it right there off the right side of the coronagraph, starting at about 12:24 on 9/27, right there. See that coronal mass ejection coming out. It is Earth-facing. We looked at it yesterday on the LASCO C3, and there was a halo. It's small and diffuse. It will still have some effect. Moving on. We see very high electron flux levels. Here's the total electron content forecast. And I don't know if this is right, folks. It looks awfully low. Expect significant GPS errors, especially around the equator throughout the day today, as electron levels are very high in electron storm levels, as we typically often see following a coronal hole wind stream. And coming off of that geomagnetic storm, we're now just in unrested conditions, I believe. Actually, we're back into calm, back to KP of 3. Please leave a comment if you saw any power outages yesterday. We see an earthquake swarm in Western South America here. Let's get started with that. On the earthquake rundown. So the first on the list of 4+ magnitude quakes happened just about 24 hours ago from when we shot this video. This one in Atacama, Chile. San Pedro de Atacama, Chile, in the Atacama Desert. One of the weirder places in the world. 4.0 magnitude at 150 kilometers depth. And we're scrolling way up the list to get to another 4 here. This one happening 9 hours later. Looks like an earthquake lull, folks. 4.6 at the Northern Mariana Islands. Out in the middle of nowhere, pretty much. Very small number of quakes of 4+ magnitude here. Surprisingly low number. Here's a 5.0 northeast of Amsterdam Island, a French territory in the middle of freaking nowhere in the southern Indian Ocean. Let's take a look at the location. Check it out. Talk about a desolate area. Just located about 2,000 kilometers west of Perth. And let's go back to the list. It's pretty much confirmed an earthquake lull here, folks. A very small number of quakes of 4+ magnitude. Here's a 4.9 in Papua New Guinea. That one's at depth 102.8 kilometers. Here's a 5.1 in Russia, right in the quite far into the continent there, nowhere near a plate boundary as far as ones that are shown on the map. Here's another deep quake at Argentina, that one at 228 kilometers and a 4.4 magnitude. Largest quake of the past 24 was this 6.2 at the Philippines. Let's look at the location of that one. And there's the interactive map of that. Most likely did get felt by lots of people, as those are populated areas there. And that Davao City looks like a place in the kind of bay that would magnify a tsunami, but we don't expect to see a tsunami from that. Moving on. Everything's looking pretty green as far as that. Here's another deep quake in Western South America, and Western South America remains my favorite spot for a larger quake, as we've been seeing deep quakes there for months and no large quakes. 4.8 at Papua New Guinea is next on the list, this one happening about 5 hours ago. 4.4 at a very deep depth there. Argentina experiencing a 523 kilometer quake at a 4.4 magnitude. That would be about a 6 if it happened at the surface. Here are the pressure maps. We're going to advance this about 24 hours on this ultra early Sunday edition. Please leave a comment if you like our space weather videos. And here's where things will be in about 24 hours from the shooting of this video. Volcano rundown. We see some volcanoes back on the list here. Let's start out with Shivaluch. It's exploding. It's producing a 13,000 foot ash plume. Please leave a comment if you've been seeing purple sunsets and sunrises and attribute this to volcanic aerosols in the stratosphere, as we've had 3 stratospheric injections this year from 3 different volcanoes. Mount Aso also producing an ash plume. This one 8,000 feet. Manam exploding. So that one's back on the list. That one was not on the list yesterday. 8,000 foot ash plume there. Karangatang exploding. 7,000 foot ash plume there. Dakono, continuous emissions, exploding, ash plume, 7,000 foot. Flight level 7,000, folks. Revenador, 17,000 foot ash plume there. Explosive activity. Explosive activity at Sabancaya, 24,000 foot ash plume. And please don't pole vault Nevados de Chilean. It could be an unhealthful result, as it is exploding and producing a 12,000 foot ash plume. Next we'll go to the magnetosphere movies. Let's start with the velocity. We'll let that play through so you get your daily 4 hours of magnetosphere data. If you don't understand magnetohydrodynamics, don't worry folks, most physicists probably don't understand it yet either. Here's the density, and we're seeing very low density. You're going to see this local dense region puffing out as a result of that very low density, very diffuse solar wind of less than 1 proton per cubic centimeter. Keep in mind the density shows low density as white and high density as navy blue. Let's make that play all the way through here. As it refreshed in the middle. And there you can see that low density wind and its effects. And here's the pressure. Let me start that at the beginning for you. And it looks like the solar wind's coming in from an angle there, as you see a large angle on the equatorial plane as well as a meridional plane view, an indication that the plasma has an angular aspect to it, folks. Anyway, there's 4 hours of data from that. Next we'll look at the ground geospace magnetic perturbations as current flows through the planet at the poles, and Hall currents spill out everywhere and indeed flow through your head. Believe it or not, folks. We are seeing significant perturbations to the Earth's B field. Keep in mind, delta Delta B is talking about changes in the Earth's B field, the B field being the field that goes through a magnet. For instance, the sun's B field is the interplanetary magnetic field, the one on which you live. We'll let that play through a second time there as we see odd equatorial magnetic perturbations. Moving on. There's the GOES electron flux, and you can see it's at very high levels, and as a result we see some charging hazards. Relativistic electrons are back to very high levels. I believe we're up to like 16,000 pulse flux units right now, and that's very high levels, and so as a result we see massive charging hazards, especially in the southern hemisphere, but some in the northern hemisphere, also around the tropics. Here's the F2 ionosphere. We're looking at 6 hours of this, and it's pretty wobbly here, and we're seeing some quick charges over the western Pacific there. That's probably something like 3 p.m. local time for India. And let's look at the last frame and keep this thing moving, as we want to keep this one short. And there's the last frame. Looking pretty charged on the nighttime side and pretty normal on the daytime side. Here's where stuff is in the solar system. And there's where it'll be in 1 week. Here's where stuff is above my head. Let me refresh. There's where stuff is above my head. If you want to draw your own sky chart, check out in-the-sky.org. We're not paid for this. We just like the site, and we like to draw in the ecliptic. Here's what it's going to be like at the end of September, folks. The majority of the snow is going to be done falling according to the GFS model by midnight September 30th. So by the time October comes, the snow will stop falling, but that's about what the scene's going to be in the U.S. Some will still continue to fall in Canada by this point. We've got links to all this stuff below the video, as we always do. We've got some lightning coming down in central Missouri. The Ozarks. Please leave a comment if you're camping in the Ozarks. If you're in the Ozarks, chances are thunder is rolling in. Here's a U.S. Doppler radar, and we see massive snowfall hitting Montana right now. Let me play the animation for you there. As this system moves in from the south, moving straight south to north. We'll show you the water vapor map in a minute. Actually, in more like a second. There's the water vapor map. I guess I was prepared. And let's zoom in on where the lightning is showing up in Missouri. Again, we see a massive pressure gradient there. Keep in mind, folks, dry air is more massive than moist air, and dry air has the ability to push wet air around. Wet air kind of just makes dry air wet, but dry air makes wet air move. And that's your meteorology lesson of the day, folks. Please leave a comment, David Schlotauer, if you're viewing this video. And now we're on Null School, looking at the jet streams in the Western world. There's the extreme meridional jet stream flow. And here's the east. We'll let that play for a moment. We've got a tripled up jet stream there over Asia. We've got some jet stream moving the opposite direction there over the Central Pacific. And doubled up jet streams in the south, looking very powerful. Thanks for tuning in, folks. Thanks, Smash Team. And today's video for censored versus hole in the ground, censored versus sinkhole, may not even exist. But stay tuned for a bonus feature anyway. And here's the view of your local yellow dwarf at 94 angstroms. We're looking at about 8 hours of solar activity here. And pretty low activity. The main thing going on is this small active region here. And again, that is cycle 24, so not particularly exciting. Enjoy your Sunday, folks. Thanks for tuning in. Visit the links below the description. Support the channel. Don't forget to like and subscribe on YouTube. Press the notification bell so that you can view the premieres live with us. And remember, when you're staring at the sun, don't drink. And if you drink, stare at the sun anyway. Just don't drive. And since it'll never be now again, may the solar wind be at your back and the atherosclerosis absent from your veins.